Hello and welcome back to the key for lesson plus homework. 0.44444.5555. Unit 44444. Lesson 5555. Alright, let's get the rest of these. I forgot to erase those. Okay, so I think all of this is if you watched the lesson, of course. 118 of you did. Nice job. The 20 of you who didn't, go watch it. Alright, so what's left? Okay, yeah, this angle. This is 90. 143, so this has got to be 37. Does 37 plus 53 add up to 90? Yeah. Alright. So this is 53. Corresponding, also vertical. Alright. Is my light on? Okay. These are all 90s. Why do we know that? Well, corresponding with this one, these are all parallel, remember? Parallel. So matchy, matchy, matchy. But then it's a line, and lines have to add up to 180, so this has to also be 90. 90. Something weird going on there. Vertical angles, 90. I don't know why I wrote 90 there. This is 90. Vertical angles, linear pair. People don't usually actually write all three of them because they know that if there's two lines crossing and one of them's 90, all four are 90. I'll write two of them. How about? That's fun. You can write all four. You can write four. You can write all four. You can write two. You could just sometimes you just see one. Okay, this is interesting. We know this little angle here is also 37. It's just like this one. I mean, we could refigure it out with arithmetic. 90 plus 53, 180 minus all that, 37 degrees. Which means this little angle up here is also 37 degrees. Oops. Ooh, what's this then? 153? Yeah, or 143. Haha, 143. I was almost tricked. And then this is 137. Right? No, I'm messing this up. Am I messing this up? Yeah, it can't be 137. 117? Nope, 127. Okay. Wow. Struggling. But that corresponds with that one. Good. Confirmation. Confirmation. This is 53 vertical. This is 127 vertical to that one. Okay, let's get some more interesting ones in here. Okay, that's 33.7. So this is 33.7 corresponding. This is 33.7 corresponding. This is 33.7 opposite interior. This is 33.7 corresponding. You could also go corresponding vertical instead of using opposite interior. Let's do some math though, because this is not. There's a triangle here. They add up to 180. This is 90. So that equals 123.7. What is 180 minus 123.7? Oh, man. Well, this has to become a 9. This is a 10, so it's 3. 9 minus 3, 6. 8 minus 2 is... Wait, we borrowed from there to make that a 10. So this is a 7. So that's 5. 56.3. Checks out. I think. And then this is 186.7, or sorry, 86.7. Is that true? So this is 93.3. Okay, I can buy that. And this is 93.3. Oh, here's going to be confirmation right here. If this agrees that this is 53. So 0.7 plus 0.3, that's 1. We'll add that in later. 33 plus 93, so 126, 127, 127. 180 minus 127 is 53. Confirmed. Do we have everything yet? This was 127. Oh, we got to do distances. Here's a 3, 4, and then 5. That's a famous Pythagorean triple. That's 18, that's 12. Ooh. That's 21.6. We don't have any corresponding triangle. Okay, this one. No. I'm gonna pause the video for a second. Okay, if you found an easier way, great. But here's a triangle with 37 degrees and 53 degrees and 90. And we have another one with 37 and 53 and 90. It's overlapping with the smaller one. So what we have here is a smaller one. Will I draw both of them? 3, 4, 5, and a larger one that is partially overlapping, which is, look, 4 plus 12, I think it's 16. And then this bottom is labeled 12. It's scaled up 4 times bigger, so this is 20. So this is 20, this whole thing, but we already know this part's 5, so this part below the line is 15. Okay, that was the key we needed, because now we can compare that 15 to this 10 and compare this unknown side to this 18. Hopefully you see, well, 33.7, 33.7, 53, 53, 93.3, 93.3. So these are similar by angle, or angle. So we have all of them. So we know they're similar. If they're similar, they have a scale factor. If there's a scale factor, we can find it by comparing. How do I want to set this one up? Let's say okay, I'm going to start with this one. 10 becomes 15, and it'll maintain the ratio of 18 growing up to be x. We don't know. This is x here. Times 1.5 times 1.5 is 27. 18 times 1.5 is 27. Okay, now we want to know what this side is. But now we know it compares to 21.6. I mean, well, let's set it up the same way, I guess. 10 becomes 15. X becomes 21.6. So now we know that going this way is 1.5, but going this way is 2/3. So what is 2/3 of 21.6? Well, 2/3 of 21 is 14, and 2/3 of 6 is 4, so 14.4. Or get a calculator out. My phone right in here. This is literally how you could do it. You would say, okay, 10 divided by 15 equals 2/3. Oh, shoot. 10 divided by 15. Yeah. 10 divided by 15 times 21.6. Wow, sorry for that. I was working so hard on being in the frame. And you can always think about it. 15 times 2/3 is 10. 21.6 times 2/3 is 14.4. I forgot my little 0.4. Okay, sweet. What's next? This, we don't have this. But we don't have very much at all over here. What's going on? Shouldn't this and this are similar? Shouldn't we be able to figure out? Oh, we gotta use Pythagoras to get this side. Annoying. I wonder if there's like a bunch of different ways I'm not like noticing. 207.36. That's the hypotenuse of this right triangle. There's the right angle, there's the hypotenuse. I squared it, got that. 12 squared, I happen to know, is 144 plus x. Oh, x squared, sorry. A squared plus b squared equals c squared. And now we square root that. Oh, what did I have? 63.36? 7.96. And now we can scale because 7.96 grows up to be 12 down here. These two triangles are similar. It's too busy. This diagram has too much stuff. 7.96 grows up to be 12, but stays proportional with the other sides, which is 14.4, which will grow up to be, oh my goodness. We can do this. Good thing I have my calculator. We're trying to get here. So we're going to 12 divided by this times this gets us there. 12 divided by 7.96. Basically 1.5. Whatever. Oh, order of operations. I gotta back up. Back up. Hit enter. Times. So we just did that divided by that. It shouldn't be 1.5. Oh, because it's almost 8. Yeah, okay, I see. Times 14.4. 21.7. And lastly, we can use the same setup. 7.96 grows up to be 12, the same way that 12 is going to grow up to be this one down here. Eighteen-ish. 18.1, let's call it. There's a lot going on in here. You know what I just realized? We could have kept using the bigger and bigger right triangles. That would have been. Let's see if we can confirm that. Which one do we want to check? I want to check the 7.96. Here's how we're going to check it. This side added up is 5 plus 15 plus 10. That's 30. And we're going to compare it with the tiniest one, 5. But to maintain the ratio with 4 plus 12 plus x. 4 plus 12 is 16, so 16 plus x. And that's 4 on the little one. 5 versus 4, that ratio, 5 to 4, is the same as 30 to all these added up, but I'm pretending I don't know this one. Okay, so that's times 6. And 4 times 6 is 24. I wonder what went wrong, because look, it should be exactly 8. So scale factor times 6, 4 times 6 is 24. This is 24. 16 plus x equals 24. X equals 8. Shoot, that means all these things are like, this is probably exactly 18 then. Whatever, I'm not changing it. I will change this one. I was off by 0.04. Did I round somewhere? What happened? Did I round this? I rounded this one, huh? Naughty. I think, this one's easy to get because this 9 is 3 times bigger than this 12 is 3 times bigger than this, so this here is 3 times bigger than this. We got them. We got every angle. Oh, this is. Did we? What is complementary? I mean supplementary with the 33.7. I feel like we did this one already. 146. Do I have a 146 on here? Oh, maybe we never did this one. It's almost too late at night for me to get this. Let's just do this. 180 minus 33.7 for 146.3. Okay. Oh. Is that all of them finally? 56.3 in there. If you can't tell, it's one of my favorites. One of my faves right there. So forgive me for not noticing these ever expando ones. Oops, where's my green? No, don't tell me I didn't bring the green one. Whatever. Just keep using the red one. Guess they were supposed to all be the same color. Whatever. Did we finish this? That's good enough. Let's get on to these other ones. That is 360. 90 plus 90 plus 33.7 plus 93.3 plus 53. Yes! 360 degrees. Now, we can actually prove this because you can draw any quadrilateral. And then you can cut it in half. Diagonal to diagonal, or vertex to vertex. And this has 180, and this has 180. So altogether 360. And every time you add another side, you add another triangle to the internal degrees. Isn't that fascinating? You can even try not to, like make it super tiny. Look, I'm only adding 2 degrees. But then once you head off to this corner, you're adding like a ton, like 170, and then the rest. So you add a whole another 180 degrees inside. And now it has 1, 2, 3, 4, 5 sides. And 5-sideders always have 540 degrees. That's the conclusion you're supposed to meet here. Yeah, oh, yep. And if you figured this out, and inside, well, you take the sides and you subtract 2, and then you multiply by 180. I don't know why I wrote it floating up there so bad. I thought there was going to be a division symbol, but there's not. Yeah, let's see. Does that work? Triangle has 3 sides, minus 2 is 1. 1 times 180. Triangles have 180. Yep, that's the formula. 180 times n minus 2. Let's write it that way. 180 times n minus 2. That is the formula for the degrees of an n-sided polygon, where n is some number of sides. Oh, let's quickly figure out a 12-sided dodecagon. 12 minus 2 is 10 times 180 is 1,800 degrees in a dodecagon, which is a 12gon. Am I off the screen? I'm off the screen, and I can't get on the screen. Fascinating. Okay. That's a famous 3, 4, 5. This is c squared. This is going to be squared c squared. So we have question mark squared plus 2.5 squared equals 6.5 squared. Okay, gotta set them up. Right. Square root's there at the end. Square root. All right. Okay, so 2 is 6. Jumping over here. This one was one where the c is the unknown, so nice. C is 26 when you're done. Here, I didn't do this one yet. 4 squared plus b squared. This is going to be b equals c squared. C is always the hypotenuse, which is 8.5. Dial that up real quick. Is 72.25. Okay, 16. 56.25 square root 7.5. Amazing. How do they do it? I did some work over here. Ooh, 144, my favorite. 12. Okay, one more. 15 squared is 225. Plus b squared equals 17 squared is 289. I was doing the squares with my kid today, and that's as far as I could get. Let's see, I learned, okay, that's 17 squared. 18 squared is 324, I think. Let me check. I should be spending my time memorizing the digits of pi, not the squares. Oh. It was 324. And then 19 squared is 361. And then 20 times 20 is 400. So I know my squares up to the 20th square. 21st square if you count 0 times 0 is 0. Right, which we should. But now can I do 280 minus 25? Let's see. Well, from 225 up to 285 is 60. Pretty satisfying Pythagorean page, I'd say. One of the best, one of the better ones. It had some decimals, but they didn't go on forever. They were just half squares and quarter squares. Ooh, oh boy, what the heck's going on here? Let's just do this real quick. Based on ratios between side lengths, which of the previous right triangles are mathematically similar to each other? Oh man. Name the triangles. I'm gonna do it on here. Zoom out just a little. You can. One of my kids right now is reading the Nurture Reader. Oh, little horsey. So 3/4 is this is right here, 9 and 12. See, we've solved this to be 12. Remember that climactic ending? There we go. So 1. Well, check the last side. Yeah, it's 3 times bigger. Well, it's gonna have to be because the third side is always going to match because of this angle. So we actually have, because of the 90 locked in, so we actually have SAS proportionality. So 1, where should I write this? 1, triangle 1, triangle 5, 3/4 equals 9/12. Okay. What's this last side? 6? Okay, got one. 6 is 1/4 of 24. 2.5 is 1/4 of 10. So 2 and 3, 2 and 3, not 2 plus 3. Dang it, I'm going to have to use an ampersand right here. 2 ampersand 3, because the ratios are 2.5 grows to be 10. And actually, I'm going to do it on the triangle. 2.5 compared to 6 is the same as 10 compared to 24. There we go. So these last ones, this is going to be this last one. What's going on here? Do not like this. Okay, no, it's not too bad. This is 7.5 as we discovered, and that is times 2 to be there, and 8.5 is times 2 to be 17. So the scale factor is 2, and and ampersand 6, and the reason is 4 grows up to be like, oh, I did, what's this, an 8? Oh, that's much easier. B is 8, so this thing is 8. 4 grows up to be an 8 and must maintain its relationship with, what should I use? Oh, they both have 0.5. Yuck. 4 with the ratio of between 7.5, and then it must grow up to be a 15. Keep the ratio. Bang. Actually, you know what? That's my favorite one. Pause the video to see more. Okay, now onto this mess. Ooh, I'm just going to start over. And I'm going to get okay, so B is 6 because parallelogram. How do I know it's a parallelogram? It says so right here. O and P and M and N. So X degrees. So they want this. What, do we already know this? It's whatever Y is. Do we know any of this? Okay, here we go. This has to be 60. So this has to be 60. So this has to be 60, X is 60. Where should I write all this? And Y is 60 also then? Where's Z? Z's way over here? That's going to be 40. Corresponding. Okay. Where? Oh man. My camera's going crazy. Is this the longest video ever? Well, it is a homework, a very complicated homework, and a very complicated lesson. And man, that first section went on for too long. What was I thinking? Okay, what was I trying to do here? 20. 15 grows up to be 20. Where did I see that? This? Oh yeah, 15. Oh yeah, 15 compared to 20 must be the same as 9 compared to A. Yeah, okay. So going backwards, 20 divided by 15 is 1 1/3. Fine, great. Times 9. 12. So A is 12. Oh, I already wrote that on there. I did that in the last video, in the second video of the last videos. So what do I not know then? C? Okay, well, 9 goes with C. How do I want to do this? The same way that 9 goes to C as 12 grows up to be 16, because 12, now this topic, I'm doing this triangle and this triangle. They're similar, and so 9 goes out to C, but 12 extends a little bit farther, 4 farther to become 16 across total. Oh my gosh. This is going to work. That's a C. This is an equal proportionality. This C's got to be 12. What a weird thing, but because okay, it's times 1.25. Oh shoot, better not mess it up. Okay, 16 Divided by 12 gives me the scale factor. Times it by 9. 12. Okay, so C is 12. We got B is 6 already. That leaves us A. Where? Oh, we already got it. We did it. We did them all. I don't know if I can go on with this. This video is too long. 35 minutes? This is a new record. Okay, now that you've seen all that, if you didn't finish this on your own, try again. You can do it. This is going to be your next quiz, and this is going to be your next test. You got to learn how to do these. Come on, vertical angles, supplementary, complementary, similar triangles, parallel lines, parallelograms. Like this little thing right here. They say all these are parallel, right? Yeah, look at all these parallel statements, blah, 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 blah. So this 3, this is this, I'm assuming this is this. Well, this is also 3. Okay? Opposite sides of a parallelogram. Do this, and I will wrap this up in another video, I guess Monday, and then maybe you'll have a quiz. Alright. So we got one more page. Wow, what a weird lesson. I think... Is this 5.4 or 4.5? 4.5 is going to go down in history. Alright, Pi Day next week. Can't wait. Say hi, little computer. Are you shy? Yeah, you're adorable. Aww.